welcome back to my course Aspects of Biochemical Engineering, and last couple of lectures we concentrate on the transport phenomena in bioprocess. Now this lecture is little bit different. This is sterilization. First I shall discuss the air sterilization, then I shall discuss the medium sterilization process. Now I told you that you might be aware that I told you in the biochemical industry, when you use any kind of microorganism, the sterilization plays very important role, and we shall have to, why sterilization plays important role, because we want to have our desired organism should grow in the media, so that we can get the our desired product. So this is for that we find since most of the fermentation processes are controlled by aerobic microorganisms. So we find two different sources the contamination may come, that one is air, another is the media. So that is why the air and medium sterilization plays very important role, and as per fermentation fermenter concerned, as per the airline concerned, those sterilization can be done very easily by injecting the live stream. For some time we can sterilize those empty vessel, reactor vessel or empty pipeline, we can easily sterilize. Now here I want to discuss the air sterilization process. Now whenever we talk about sterilization process, we come across three type of that killing of microorganism process, and these processes are sterilization, thermization and the pasteurization. So you look at this is called sterilization, thermization and pasteurization. Now what do you mean by that? Sterilization we means that killing of all the living microorganisms, both pathogens. So killing of all living microorganisms, both pathogenic and non-pathogenic, including the spores, are killed. But what is thermization? It is partially removal of pathogens. Now let me give a very typical example. The dairy industry, suppose they are using the milk, am I right? Milk is their product, and we know milk is the best media for the growth of pathogenic organism like mycobacterium species, we have Shigella, the different type of pathogens, they can grow very easily. So suppose the dairy industry, they are working 6 days in a week, and Sunday, let us assume that Sunday is the holiday. So suppose some milk reached to the counter on the evening of Saturday. So they have to keep this milk for more than 1 day, and this is the good time to grow of the pathogenic organism. So even they put the milk in the chiller, that your microorganism will grow and spoil the milk. So what did they have to do? They reduce the microbial load that present in the milk, and this is done, this reduction of microbial load with respect to without concerning the pathogen and non-pathogen, just to reduce the microbial load, so the storability of the milk can be increased. So this is called thermization process. And now the third thing is the pasteurization process. It is the reduction of the number of viable pathogenic organisms, because we know that two type of organisms are there. One is called pathogenic organism and non-pathogenic organism. What is pathogenic organism? They are harmful to the human health, and non-pathogenic organism that is not harmful to the human health. We were working with the biochemical industry, mostly we concerned with the non-pathogenic organism, not the pathogenic organism. So pasteurized milk, that means it does not contain any pathogenic organism, but it contains non-pathogenic organism. That is why we cannot preserve the pasteurized milk for a longer period of time, because after 3-4 days you have to throw the milk out. Now there are different methods of sterilization process. Now we have it can be divided into two types. One is the physical, another is chemical. Am I right? Now physical, whatever we have sunlight, we have heat. Heat we have different type, dry heat and moist heat, and we know the moist heat is more effective for sterilization. Then we have vibration, then radiation. We have two type of radiation, non-ionizing radiation, ionizing radiation. Then we have filtration, different type of filter we can use. Now, in the chemical we use the different alcohol. We know that in the hospitals or any pharmacy, that when you got the surface sterilization, we largely use the alcohol, the aldehyde, phenolics, halogens, then heavy metals, surface active agents and dry. The gaseous is formaldehyde, ethylene oxide, plasma, and iodine, that is also used, what we call halogens. One is called iodine, that is largely used, or chlorine also largely, that is a strong oxidizing agent. Now, for air sterilization, what is the main purpose of air sterilization? That main purpose is the remove of airborne of microorganism present in the air for aerobic fermentation process. And there are wide variation in the quantity of suspended particles of air in the atmosphere outdoor. There are different type of organism might be present in the air, and the microorganism may vary in the range 10 to 2000 per cubic meter, while the suspended particle may vary 20 to 10,000 per cubic meter. Here I want to tell one interesting thing, that usually the biochemical industry recommend that it should be the higher altitude, and we assume in the higher altitude the amount of suspended particle will be less, and if the amount of suspended particle less, the microbial contamination also should be less. Among the microorganism presence, the fungal spores 50% and gram negative bacteria 40% are dominated. This is usually the case we have observed in the air. Now, question comes, what are the method of how air can be sterilized? Air can be sterilized by different means. One is filtration, another heat and the ultraviolet rays or other electromagnetic waves, and the chemical agent. Now, filtration we understand very easily that if you have a filter, suppose if this is a column, and if you have a filter, you pass air and take it there. So, whatever suspended particle present here, that we have fiber here or membrane here, that that particle entrap in between that. Suppose membrane, if you have membrane has some pore size, and if you want to separate the bacteria, and we know the bacteria size is 0.5 to 2 micron. So, if you so your pore size is less than 0.5 micron. So, all bacteria, if you pass, all bacteria will be retained by the that membrane. So, this is the this filtration can be done with the help of membrane, with the help of fiber, different ways it can be done. And that heat can be used, but a problem of heat, that when we consider air, sterilization by heat is not recommended. Why it is not recommended? Because the air is purely conduction of heat. So, you require more heat for the sterilization of air, which is not recommended. Then ultraviolet rays and other electromagnetic waves, because two type of airs we have, one is moving air and another is stagnant air. Now, we know all the operation theaters, we have seen that usually that is sterilization done with the help of ultraviolet rays or other electromagnetic waves. Mostly ultraviolet rays we use. Even we in the lab we have the laminar flow, their laminar flow where we transferred our culture, that this sterilization is done by the help of UV rays. So, that is usually recommended for the stagnant air, not for the running air. And another is the what you call chemical agent, that I told you, chlorine. We spray chlorine in the room, so that room will be more or less sterilized. So, this is the mechanism through which we can sterilize the air. Now, for running air, that in between the filtration and the heat, we usually go for filtration, because filtration is usually used in the industry for the separation of contaminants present in the air. Among these, industrially, the heat and filtration are the most commonly used. Heat is ineffective in case of air sterilization, and due to low heat transfer efficiency of air as compared to with the liquid. Thus, more effective technique of air sterilization is filtration with fibrous and membrane filter, just I discussed. Now, filtration, that what is the purpose? They allow the exclusive the organism based upon the size, just now I explained, does not destroy or remove the microorganism, because you know that when you talk about the removal of organism by heat, heat means what? When you heat the organism, that the protein present inside the cell, they undergo denaturation, and due to denaturation of the protein, most of the enzyme will be inactivated, and since the enzymes are inactivated, then the properties of the cells will be lost and the organism will be killed. Am I right? But in case of filtration, it is not the destruction of the cells. You physically separate the cell from the air. So, this is exactly does not destroy but remove the microorganism. Filtered sterilization depends upon the content of air like suspended matter, its size and type of moisture. I want to point out here that I work with citric acid industry. In citric acid industry, we use the Aspergillus niger for the production of citric acid, and we found the yeast is the major contaminant, because if bacterial contamination is there, we do not have any problem. So, if you look at the bacteria, each size varies from 3 to 7 microns. So, pore size obviously it should be less than 3 microns, then it will, our purpose will be served. Now, HEPA filtered, HEPA means high efficiency particulate air. The filter can remove 99.97% of particulate of -3 microns in diameter, greater than 0.3 microns diameter. Air is first passed through the pre-filter to remove the large particle and then passed through the HEPA filter. Pre-filter, why it is required? So, the load in the HEPA filter will be little bit less. Now, there are different principles through which the air can be separated through the help of air filter, and these principles are several. One is called inertial impaction, interception, diffusion, settling by gravitational force and the electrostatic force of attraction. Now, what is called inertial impaction? Suppose this is the cross section of the fiber, am I right? The fiber, if you cut it, and cross section of the fiber is this. Now, air is flowing perpendicular to this fiber. So, air will be flow like this, am I right? It is flowing like this. Like this it will be flowing this way. Now, suppose the particulate present here. So, your particulates will go like this and it may not touch the surface of the fiber. So, if it does not touch, then your particle will not be collected by the fiber. Now, if you increase the velocity of the air, then it will be one initial force, and due to Newton's first law of motion, it try to maintain the same path, and when it maintains the same path, then it slowly it will deposit on the surface of the fiber. This is called inertial impaction. Interception means what? When particle present here, when it goes, suppose the radius of the fiber is equal to the width of this this surface and the stream, then it will touch the surface of the fiber, then it can be collected. And what is called diffusion? Suppose this particle, diffusion occurred at the very low flow rate. One particle strike with another, the Brownian movement like this, and ultimately it might be deposited on the surface of the fiber. This is called diffusion. Now, settling, since the particle, we target very small amount of particles. So, the naturally small amount of particle through gravitational force may be neglected. And electrostatic force, if you look at, we have seen the microorganism, same microorganism as for example, the Bacillus subtilis, it does not have the uniformity of charges. Maybe some 50% positive, 30% negative or 20% neutral, maybe like this distribution is there. charged particles may be attracted to the opposite surface of the media, and since the microorganisms have the different charges on the surface, the electrostatic force can be neglected. So, if the microorganism has one specific charge, then the particle separation through the electrostatic force can be considered, and also mass of the microorganism is very less, settling due to gravitational force can be neglected. So, we will consider three different things. One is inertial impaction, interception and diffusion. We assume a couple of things to explain that. Let us the single cylindrical fiber are placed perpendicular to the aerosol floor in a infinite space. Airflow around the cylinder is lamellar with no vortex, and analysis are two dimensional. These are the three assumptions we make to explain these principles. First principle is the inertial impaction, I told you, and suspended particles in the air stream has a momentum. The air at which the particles suspended flow with the filter route at least resistance. However, the particle because of their momentum tends to travel in the straight line, and thus the flow pattern of the particle deviates from the airflow due to the inertia of the particles as they approach to the cylindrical surface due to the first law of motion. So, here we consider one critical air velocity. That means, what is critical air velocity? Critical velocity air velocity is the velocity above which the particle will be collected due to the inertial impaction, because it try to follow the same path. Otherwise, above the critical less than the critical air velocity, it will follow the normal air path. Then the inertial impaction will not work. Now, this is an example I have given. I have already told you. This is a particle moving. This is how it is depositing on the surface of the fiber. This is how this is depositing. Now, here that collection efficiency of the single fiber by inertial impaction can be given eta 0 equal to B by dF. B is the width of the stream, that this is the fiber. So, effective width, we shall have to find out up to what width that this is effective. Suppose this is B and this is diameter of the fiber is dF. So, this is the collection efficiency due to inertial impaction is this, and this will be equal to 0 when psi equal to 1 by 16. What is psi? Psi called the inertial parameter, and this is C rho p. C is the Cunningham factor, rho p is the density of the particle, dp is the diameter of the particle, b0 is the velocity of the air, mu is the viscosity of the air, df is the diameter of the fiber. Now, at the critical velocity, Bc psi is equal to this, as this Bc equal to this. So, in a velocity more than that, then and only then it will work, less than that it will not work. Now, in case of interception, I told you this is how it happens. This particle moving like this, and when it moves, it touches the surface of the fiber. This particle can allow in the flow stream in the air around, and the particle will contact the fiber and to be removed. This, if the particle removed through this, we call it a particle through the inception. The interception, that is can be expressed like this. This is equal to eta 2 it is 0 2 is equal to this 1 by 2 into 2 minus ln n RE. NRE is the Reynolds number, and NR is the geometric ratio. What is geometric ratio? dP by dP. dP is the diameter of the particle, dF is the diameter of the fiber. So, this is how we can determine. Now, diffusion, I was telling that extreme small particles suspended in air subject to Brownian motion, which is random movement due to collision of the fluid molecules, and such particle may collected on the surface of the fiber as the particle are displaced from their median or median center of location. This is how one particle it strike with another particle will strike with another particle, then ultimately it deposited on the surface. This usually occurred when air flow at very low velocity. Now, one thing I can tell you, now if you consider that overall collection efficiency eta 0, if you plot with respect to velocity that of the air, the surface velocity of the air, we will find the plot like this. Now, what does it mean? That mean that as the velocity increases, that your overall efficiency decreases, then again increases. So, that we find this is like this. This is 3 different part, 1, 2 and 3. Now, we find that that here particle mostly collected due to the process of diffusion, here particle mostly collected due to the process of interception, and here particle mostly collected due to the process of inertial impaction. Now, the particle separated by diffusion can be explained like this. Only here you can see that here you consider the NR. NR is the geometrical ratio. Am I right? Now, here this NR is replaced by 2x0 by df. 2x0 is the displacement. Path of this is the displacement of the particle is 2x0. If you consider, and if you replace by that geometrical ratio, you will get the particle the collection efficiency of the particle due to diffusion. And this 2x0 by df can be is equal to this one, 1.122 into 2 minus log RE dBm, and where dBm is the diffusivity of the particle. So, overall collection efficiency will be what? Overall collection efficiency eta 0 dash 1, eta 0 2 dash, eta 0 3 dash. Now, this interception is touching this fiber, and diffusion one particle that strike and ultimately deposit on the fiber, and this is the impaction, inertial interception, and impaction is that it deviates from the path. When it deviates from the path, it collected on the fiber surface. This can be explained like this. Now, that we find that the overall collection efficiency is proportional to NR square n RE to the power 1 by 6, and the N0 is that 2 dash is the proportional to Smith number minus 2 by 3, Reynolds number minus 11 by 18. Now, the experience of particle sterilization by air is that the collection efficiency due to inertial impaction generally predominant at the higher velocity. So, the collection efficiency eta 0 can be disregarded, calculated eta 0 at a low velocity less than 10 centimeter per second. In the case I showed you how where at a higher velocity the particle separated due to inertial impaction is considered. Now, overall collection efficiency is calculated in N1. Suppose this is a fiber, this is a filter, and you pass air, and air in is N1, and this is N2. So, removal efficiency will be what? N1 minus N2 divided by N1. Am I right? This is how you can, and single fiber efficiency is what? Equal to pi df 1 minus alpha. What is alpha? Is the fraction of the fiber. That 1 minus alpha is the void fraction, and L is the length of the fiber. What is this? Is the thickness of the fiber. This we can design, and this is N1 by N2. This is the we have given here. Okay. So, this can be written in this form. This can be written single fiber efficiency can be written in this form like this. Now, this now here one thing is that this equation indicates the fraction of the particle collected in any section within L, when within L is constant, which is known as log penetration relationship. L should be less than 4 centimeter. The correlation between N alpha and N 0 is like this. The N alpha is the single fiber efficiency, the eta 0 is the overall collection efficiency. So, this can be now eta 0, that if you use the normal procedure, the theoretical things, you have to, this is eta 1 dash, eta 2 dash plus eta 0 3 dash. So, one is the inertial impaction, one is the interception and diffusion. But here if you use this correlation, that eta alpha and eta 0, so if you know the eta alpha value, or if you know the eta 0 value, we can easily calculate eta alpha value, and if you know the eta alpha value, we can easily find out the that L is the thickness of the air filter. We can design like this. Now, this is the correlation that we have. This is very interesting correlation. This is I have taken from biochemical engineering by Iva Humphrey. This is eta 0 in R in PC equal to P, that PC is the peaklet number, P, NR is the reaction number, that then it is Reynolds number. So, you can write like this. So, here you see that if we plot that, we can from the flow characteristics of the fluid, we can find out what is the NR value, what is the NPCP value, peaklet number, and N0 value. And if you know that corresponding value here, we can find out. And if we know the corresponding value, no, sorry, if we can have this value, from this we can find out this corresponding value. Now, here you have eta 0 value. So, we know the NR, we know NP, so we can easily calculate the value of eta 0. Eta 0 is the estimate is a specific set of conditions with the help of to determine the value of the that thickness of the filter. So, if you know that, then eta 0 value, then what we can do, we can find out the eta alpha value. If you know the eta alpha value, then I showed you that if you know the eta alpha value, then this is eta alpha, this is so this is eta alpha, this is eta alpha. So, if you put eta alpha, TF we know, alpha you know, if you that collection efficiency you know, then we can easily find out the thickness of the air filter, that we can design the air filter very easily. Now, question comes, what should be the selection criteria of the air filter? There are several selection criteria. One is the filter retention efficiency, how much efficiency is there. Now, here I want to tell you one important thing, that whenever we talk about the retention efficiency, that how much, that means how much organism it can retain, what is the total, how long, that means indirectly how long this air filter can be utilized. Then economy of the operation, how economic, how much money you spend for that, age of the air filter, how easily you can use the air filter, and service provided by the manufacturer. These 4 factors that plays very important role for selecting the air filter. Most important selection criteria of the filter efficiency and reliability of the organism retention. Fixed sub-micron pore size membrane filter provide the highest level of filtration efficiency. Now, membrane filtration we have some problem, because we know membrane is a very weak material. It is a membrane, usually polymeric material, and as your pore size decreases, the pressure drop across the membrane will be very high. If the pressure drop is very high, there is every possibility that bursting of the membrane material. So, life of the membrane reduces significantly. Hydrophobic filtering material minimizes or eliminates concern of filter wetting due to the air moisture. So, these are the couple of factors we shall have to consider for selecting the air filter. Now, another important thing is that what are the different type of filters available. One is called depth filter, another is the membrane filter. Depth filter means it consists of either multi-layer or single layer or of a media of depth which captured the contamination of the structure. I can give the example of hollow fiber membrane. It is a depth filter. It is not not a membrane type of filter, but a membrane means it is kind of a the sheet type of material. Is the membrane filter is typically trap contaminants large size pore address the surface of the membrane. The depth filter particle penetrates the structure of the fiber and filter cake of the surface, and membrane particle. So, what I want the membrane, we have a particular cut up size, that if the size is less than that, more than that, that cannot penetrate. But in case of this depth filter, it is a very thick. So, in between we have fiber, in between it will be this also depends on the pore size, but it depth that we have. Now, it is in case of depth filter, it is assumed that a particle touches the fiber, it remains the touch to it, and there is a uniform concentration of particle at any given depth of filter. Then each layer with of a unit thickness of the filter should reduce the population entering in the same proportion, which may express mathematically like this. The dn by dx, dx is the thickness of the filter, k is the constant n into n. So, the n is the concentration of the particle and k is the constant and x is the depth of the filter. So, this we can write n by n0 equal to e to the power minus k into x. So, this we can rewrite this form in this and then efficiency we can calculate E equal to n0 by n by that I have shown you like this before. Now, this again we can write in this form, and finally, the log this is interesting thing, log penetration relationship can be used for the filter design by using the concept x90. What is the x90? The depth of the filter required for the removal of 90% of the total particle entering the filter. Now, suppose n0 is the 10. So, x90 the n should be 1, am I right? Then our relationship equal to n by n0 equal to k into x90. So, we can write x90 equal to 2.303 by k. So, we can easily find out the value of x90. Now, this is the kind of correlation that we have, the value of k value affected by nature of filter material. So, this is the linear velocity and this is the k velocity. Your k value, if you look at this is decreases and then it is increases like this, am I right? And x 90 value that will increase, then it will decrease like the n, it will. The k increases to a optimum with a increase of air flow rate, after which it increases the result in the decrease of k value, that that has been observed, that it increases, then it is decreases. So, this is kind of scenario that we have in case of air filter. So, in case of depth filter, the increase of k with the increasing of velocity, probably with the due to the increase of impaction, this illustrates the important contribution of this mechanism makes to the removal of organism. Decrease of k value at the high velocities probably due to the disruption of the filter, allowing the channels to develop and fibers to vibrate and resulting the release of previously capturing organism. So, that that I want to, another thing I want to tell you here, that after suppose whenever we use any kind of filter, after sometimes we will find that the filter is totally saturated with the particles. Then if you pour air, then there is every possibility that some contaminants will comes in the air. So, you have to regenerate the filter. Now, how you can do the regeneration of the filter? Because we can do it very easily. Suppose this is the filter we have, and this is the so here we put some kind of heating rod here, and we pass air at very low flow rate, and we have restricted the flow, and this is heat, we put it is connected heating rod, and we try to heat this media and circulate this, and we try to circulate the air in such a way, so that all the organism presence inside the filter that should be that will be killed, and then we can start the we can reuse again for the air filtration purpose. So, this is how we can do the regeneration of the process. Now, membrane filter, that is a fixed pore I told you, and which is very widely used in the fermentation industry, but it has very low life, and pre-filtered from the trapping the large particles such as dust, oil and carbon, pipe, scale. And this filter are made of varieties of polymeric materials such as cellulose nitrate, cellulose diacetate, polycarbonate and polyester. These membranes has a pore diameter 0.015 microns to 12 microns. These filters are sterilized by autoclaving. The membrane filters are made of two ways. Capillary pore membrane have pores produced by radiation, while the Rabelais-Thins pored membrane are produced by forced evaporation of solvent from cellulose ester. So, this is the only the problem is that the life of the membrane is very less, and this is how the industry we use the filters, that this is the fermenter that so we use some kind of pre-filter, and before we pass this to the fermentation industries, that we pass this liquid like this. The due to hydrophobic filter system, the sterilization of gas from the air filter. So, whatever gas is going out, that we sterilize, that also we sterilize, so that it should not contaminate the air. So, in this particular lecture I try to cover the air sterilization process, and air sterilization is very important as our biochemical industry is concerned, because and I told you three methodology through which we can remove the microbes. One is called sterilization, remove all the microbes. Pasteurization, only we remove the pathogens, but when we remove pathogens, some non-pathogens also remove, but our target is pathogens, but thermization process just to reduce the bacterial load. Now, we have discussed the different methods of air sterilization process. We find that filtration is the best technique for air sterilization process for the moving air, and for the stagnant air we use the UV rays, or we use some kind of chemical disinfectant like chlorine or iodine that we use for the disinfection purpose. And this and now when you talk about the removal through the particle removal through the filter, there are the different principles involved for the removal of the filter: inertial impaction, compaction, interception, diffusion, and cavitation, and the electrostatic force of attraction. Since the charge distribution in the cell are different, so particle separated due to the charge may be neglected, but and also size of the particle is very small. So, naturally that gravitational force can be neglected. So, particulate separation with the help of inertial impaction, interception and diffusion, that was considered to find out the overall collection efficiency. The overall collection efficiency can be estimated with the help of the correlation between eta alpha and eta 0, and where alpha values alpha is the volume fraction of the filter that presence, and I told you 1 minus alpha is the void fraction of the filter, where the air can void fraction, the air can move, solid fraction air cannot move. And then I try to discuss the design aspect, how to determine the thickness of the air filter, and finally we come out the two type of filter, and depth filter and membrane filter, how it can be worked out, and finally we discuss the what are the should be the criteria for selecting the air filter. Thank you very much.